All right. So rational fractional equations are when we have a rational fractional expression set equal to another one. Rational fractional, okay? So it's solving equations, which is kind of nice. And it took me a lot of years. There's so many different ways to teach this. And so the way in Delta Math is very different than how I'm going to teach you to do it, okay? But let's start with some logic. And I really love logic because it makes us realize how easy this really is. When I look at this rational equation here, don't work too hard. What must x be? 5. Look again, ladies and gentlemen. Those two things are equal, right? Do you have to figure anything out? Do you have to cross multiply? Do you have to do anything funky? If they're equal, shouldn't this be a 5? Yeah? Because that's what the property of equality says. Right? These two things match. Shows that these. All right. So now, look at this one. What's x? 3. Oh, okay, good. These denominators match, so that means that this must be a 3. 3 plus 2 to equal 5. That makes sense, yeah? Logical, yeah? All right, and so then something more complicated. What must x be? 2. Right? Did it take any work at all? No work at all. Okay. I'm not saying that today won't require work. It will. But what I'm saying is, if all the denominators match, do I have to think about them? No. They're already equal. I don't have to think about them. So once we have lovely common denominators, I get to forget about them, which is pretty darn nice. Okay? And that makes perfectly logical sense, doesn't it? If the denominators match, then let's just focus on the numerators. And that's all we have to do. And by now, we're quite good at getting common denominators. So that's what we are going to do today, get common denominators, and then we get to forget about them, which is pretty nice. Here we go. Example 1. Identify undefined values of x. Always something to think about. And then solve. Identify the undefined values of x and then solve. Make sure you get example 1 and the directions. All right, problem A here, we have x over x minus 8 plus 3 equals negative 4 over x minus 8. So the first thing we want to do is figure out some values of x that are undefined. Where do undefined things come from? Variables under the bar, okay? So undefined comes from underneath. So when we say x minus 8, the denominator is not allowed to equal 0, what value of x is that? Yeah. X cannot equal 8. That is something that would give us an undefined value, okay? Every other x value is going to work just fine, but we can't use 8. 8 is a no-go. So from there, we need common denominators. What's the denominator on 3? 1. Excellent. Good. And I have this beautiful denominator here, this lovely unique factor of x minus 8. And here's another one, x minus 8. They both have a denominator of x minus 8. What does this fraction need? X minus 8 on top and bottom. So we're going to smush it in there. And now we have wonderful common denominators. And once we get those denominators equal, do I care about them anymore? No, logically, they're already equal. I don't have to do anything anymore. They're equal, and we can forget about those denominators. And all we're left with is what's on top. So what do we have left over? What's in my numerator? X. I have a plus sign. Then I have 3x minus 24. Very good. So you went ahead and distributed. Good. 3x minus 24. Beautiful. 3 times x. 3 times negative 8. Negative 24. Good, good, good. Love that. And what else do we have? Equal to negative 4. Don't forget that negative. We're going to put it with the top. That is perfect. Beautiful. How easy was that? All we have to do now is solve. Yay. Hello, August. We're back to see you again. All right, 1x plus 3x's is, good, minus 24 is equal to negative 4. And then we can do what? Add 24. Perfect. We get 4x is equal to 20. Good. And then we can divide by 4, and we get x equals 5. Good. That is the solution. The only thing I have to worry about is if that solution for x happens to be undefined. It won't work. All right, this will work. We could plug it in and check, but I'm not going to bother today. That's the beauty of solving equations. You can't always check the answer. It's kind of nice. All right, letter B, we have x plus 2x plus 5 over x plus 6 equals 2. All right, where is this rational equation undefined? Negative 6. All I have to do is negative 6 would give us a 0 in the denominator. Okay, we could solve it, but that's pretty easy to see right off the bat. Negative 6 plus 6, 0. That's not allowed. Okay, we've got denominators of a couple of ones there. I'm going to pop in. I have this wonderful factor of x plus 6 on one of the denominators. So what does this first fraction need? X plus 6, top and bottom. Beautiful. Good. And over here we need x plus 6, top and bottom. Mind the parentheses. Okay. Great. Do the denominators match? They're already equal then, aren't they? So we can ignore them. And we are left with what? Good? Good. X squared plus 6x. Very good. So we're distributing the x. X times x is x squared. X times 6 is 6x. Beautiful. We have a big plus sign. 2x plus 5 equals, and then over here we're going to distribute as well. Distributing the 2, we get what?
2x plus 12.
Perfect. 2x plus 12. Beautiful. All right, this first equation was linear in that it was x to the first power. That's always easy to solve. This one is quadratic, squared. Okay, so this one is a little bit different, but we're still going to clean it up. Before we do anything, I have x squared. 6x plus 2x is 8x plus 5 equals 2x plus 12. And anytime we have a quadratic, we need to set it equal to 0 and factor and solve. So we're going to go ahead and I'm going to move these two terms to the left side. So I'm going to subtract 2x and I'm going to subtract 12. That way I have a 0 on one side. I always want my x squared to be positive, so I'm always going to move the terms around so that my x squared is a positive result. Let's see, 8x minus 2x's is 6x's, and 5 minus 12 is negative 7. Good. And we are getting so good at this now, we're going to factor and solve. Double bubble. X times x is x squared. What times what is negative 7?
Positive 7 and negative 1.
Excellent. Positive 7 times negative 1 would give us that negative 7. And when we add them together, we get a positive 6. What do we do after we double bubble? Set each bubble equal to 0. So x plus 7 equals 0, x minus 1 equals 0, and then we can isolate x, which means x equals negative 7. Beautiful. And over here, x equals positive 1. We are isolating x. These solutions will both work. They're not undefined, which is good. Okay. All right. Questions on these? I think really fast, I'll just show you. You can just watch just to be sure. We can always check just to make sure. I'm just going to check check the solution of 1 just so you can see. Back to the original. I'm only going to use the original equation. Okay. I'm going to plug in a 1 for x plus 2 times 1 is 2 plus 5 is 7. Here in the bottom, 1 plus 6 is 7 equals 2. 1 plus 1 certainly equals 2, right? So easy to check. And we're going to be doing more of this sort of plugging in with fractions here. So it's good to practice. All right, is this the, oh, I have 2 more, okay. Letter C, 2x over x minus 1 plus 7 over x minus 7 equals x over x minus 7. Undefined. Where are we undefined? What values of x are bad? 7. Yeah, x is 7 is undefined. What else? 1. Yeah, 1 minus 1 would be 0. So we have 2 values that are undefined, which means that we get a 0 in the denominator. 1 minus 1 is 0, undefined. 7 minus 7 is 0, undefined. When the 0 is under, it's undefined. And those are the values that get us there. All right, looking here at our lovely rational equation, we have x equals negative 1 as a big, beautiful factor. And we have x minus 7 as a big, beautiful factor that happens to be already have a match. So that's kind of nice. Our goal is to get common denominators. What does this first fraction need?
Subtract 6.
Oh, we can't add or subtract. We can only multiply. We need the entire bubble there. It needs that x minus 7. Top and bottom. So that it has a green thing and a pink thing. What does the second fraction need? X minus 1. It needs the green thing. Top and bottom. Squish it in there. And I will say that having a color really, really helps this, I think. Pink and green. Good. What does the last fraction need? X minus 1. That green thing. Got to have a pink thing. Got to have a green thing. 2 bubbles on that denominator. Now each fraction has our 2 little bubbles, our 2 little factors that match, and we can ignore those denominators. And we are left with just numerators here with a bit of distributing to do. We're going to distribute a 2x. 2x times x is 2x squared. 2x times negative 7, negative 14x, beautiful. Plus 7 times the quantity x minus 1. What is that? Minus 7, good. And here we're going to distribute the x. What do we get when we distribute the x?
X squared minus 1x.
Good, x squared minus 1x. Perfect. Beautiful. Again, we have things that are being squared. So we're going to set all this equal to 0. And once again, I'm going to take these things and move them to the left here. So I'm going to subtract an x squared, a 1x squared, and I'm going to add a 1x. Oh, I didn't combine. Oh, well, that's okay. Jumped the gun a little bit there, but that's all right. All right, let's see. 2x squared minus 1x squared is 1x squared. Good. I have quite a few of these plain old x's here. Negative 14x plus 7x is negative 7x. Plus 1x is negative 6x. Good. And then we have our minus 7. Well, that looks familiar, doesn't it? Okay, we have negative 7x's plus 1x is negative 6x. Perfect. And then we can factor and solve now. So we're going to double bubble. X times x is x squared. What times what is negative 7? Negative 7 and positive 1. And when we combine those, we would get a negative 6, which is where our middle term comes from. All right. How do you solve for x?
0.
Set the bubbles to 0. So we get x minus 7 equals 0 and x plus 1 equals 0. And then, well, it's really easy to see that x equals 7 and x equals negative 1. Ooh, I love that you saw that right off the bat. What is x equals 7? Undefined. So does it work? No, it doesn't work. It's not part of the solution. We already said it can't be 7 because we know it's undefined. If I plug a 7 back into my original function, we would have 7 over 7 minus 7. 7 minus 7 is 0. And that would be undefined. Negative 1, totally fine. So this is our one solution. Questions on that? This is why paying attention to when things are undefined is the first step. Okay. All right. One more and we're done. Letter D, 1 over x plus 3 plus x plus 7 over x minus 1. Equals 3x plus 5 over x squared plus 2x minus 3.
Pretty big denominator.
Pretty big denominator there. Factor that, yeah. We need to double bubble this guy. We can see that if you see something that's like, hey, that's kind of big, you want to make sure F-I-R-S-T, factor first still applies. So this is definitely going to be able to be double bubbled here. X times x is x squared. What times what is negative 3?
Positive 3, negative 1.
Good. Positive 3 and a negative 1. Excellent. And what's really helpful about that is I can see that I've got a big x plus 3 in pink and a great x minus 1 in green. And you can see I've already got the good little match there, a common thing. And I got an x plus 3 here in common. All right. So this has 2 cute little bubbles here. What does this fraction need? X minus 1, the entire thing. Don't shortcut it. You need the entire bubble. X minus 1 on top and bottom. We got a pink and a green bubble. What's the second fraction need? X plus 3, top and bottom. Ooh, that one's harder. X plus 3. Here we're multiplying this entire numerator. Ooh, this one is a bubble times a bubble. That's a lot of factoring on that one. Do I need anything over here with our last fraction? No, it's good. It's got the pink and green bubbles already. Okay? So that one's all set. All right, we've got our matching denominators now. Everything has a pink and green bubble. Pink and green, pink and green. So I can ignore those. I am going to go ahead and take an extra step here and write this out. 1 times the quantity x minus 1 plus x plus 7 times x plus 3 equals 3x plus 5. And the only reason I'm doing that is because this is a big... Have I ever used the word FOIL with you guys? No? Yes? Sometimes you might have heard it. Have you heard it before? Oh, okay. It's just distribute. But I use distribute more often, but first, outside, inside, last is the acronym. Anyway, it doesn't matter. It's just distribute. We're going to go ahead and distribute. What's 1 times x minus 1? X minus 1, okay. And then here we are going to make sure, and you had to do this yesterday, I believe, but x times x is x squared. The outside here is 3x. We're going to distribute the 7 as well. 7 times x is 7x, and 7 times 3 is 21. So that's what the acronym stands for. First times first. The outside terms there. I is for the inside pair, the two inner parts, and L is for last times last. Okay, but it's not important. That's not annoying at all. Okay. All right, I'm going to definitely do some cleanup here. I have an x squared. I have a 1x plus 3x plus 7x. What is that? 11x's. I have a negative 1 and a positive 21, which is 20. Good. Is equal to 3x plus 5. And again, because it's squared, I'm going to do the same thing as before. Set equal to 0. Oh, you know, what didn't we do?
Undefined.
Yeah, whoops-a-daisy. Sorry, let me pause. Where is our rational fractional function undefined? Good. X equals negative 3. Negative 3 plus 3 would be 0. So that's an undefined value at negative 3. And positive 1. 1 minus 1 would be 0. So sorry about that, I forgot. So easy though, right? So easy to check. All right, I'm going to go ahead and subtract 3x, and, subtract 5. Subtract 5. So we get a 0.
Squared plus 8x plus 15.
Perfect, thank you. X squared plus 8x plus 15. Good, good, good. And then we can double bubble. We're getting so good at double bubbling now. First times first has to be the first thing. Last times last has to be the last thing. What times what is positive 15? 5 and 3. Positive 5 and positive 3, which means x equals, yeah, or negative 5. Or, that's right. So move the 5, we'd get a negative 5. But negative 3 is undefined. So that one doesn't work. And our only answer here is negative 5. All right. Do you have questions for me? Or is this pretty easy? I like it. And once I realized the logic behind it, it made it a lot better. Okay. Folks, you have a little Delta Math. Please make sure you're getting all your homework done and all caught up so that Monday you just have to think about reviewing for your test. Okay? Yeah. all we're doing, just reviewing on Monday.